Hello everyone, today we're going to be reviewing 11 geometry problems from the 2013 student handbook. This is Form A, and the test, you can find the link to the test in the description of this video. We're going to be starting with number 58. The figure above is drawn to scale. Which point best shows the location of C plus A, comma, D plus B? First thing you can take away is that this is in point form because of the comma. So you know that C plus A is going to be your x-axis and D plus B is going to be your y-axis. Second thing is that you know it's drawn to scale, so we can literally just count these out. And then the other notable thing is that we have a y-axis labeled and x-axis labeled. So now we have to find C plus A and D plus B. So we'll look at C. C is on the right side of the x-axis, which means it's positive. So this is positive 1. 1 plus A, which is negative 2, 1 plus negative 2, comma, D plus B, D is 3 above, positive 3, and B is 1 above. So now we have 1 plus negative 2, which gives us negative 1, comma, 3 plus 1, which gives us 4. So we can count this out. Here's our negative 1. Now we go into our y-axis 1, 2, 3, 4, and we get point R, which is F. Okay, moving on down to number 57. It says, how many units is it from the midpoint of PQ to the midpoint of QR? Personally, I think the whole crisscross method is not reliable, so we're just going to be using the midpoint formula, which is 0.1 plus 0.2 divided by 2. So it wants us to find, first let's find the midpoint of PQ. So it's going to be negative 6 plus 2 divided by 2. Negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. So the midpoint is going to be negative 2. Next we have to find the midpoint of QR. We'll do 2 plus 6 over 2, which is 8 over 2, which gives us 4. And right here is our midpoint. Next we can just count 1, 2, 3, 4, 5, 6. Answer would be C, 6. Alright, moving on to number 65. On a scale drawing, a distance of 1 foot is represented by a 0.25 inch in length. How long must a segment be on the scale drawing to represent a 36-inch distance? You're given a rate, which is 1 foot is equal to 0.25 inches. And that's for the scale drawing. And you're also given, and you want to find how 36 inches relates to the scale. So 36 inches is in real life, and you want to find how it will be on the map. So you know 36, you know there are 12 inches in a foot. So you can, if we convert the 36 inches into a foot, we can apply it to our ratio right here. So we'll do 36 inches divided by 12 inches per foot, and that'll give us 3 feet. Now that we have the same unit, we can plug this into our ratio. We have 3 feet. We have 1 foot is equal to 0.25 inches. 3 feet is equal to x inches. 1 times x is always going to be x. So we have x inches is equal to 0.25 times 3, which is 0.75 inches, which is B. Nice. And coming on, number 69 right here. This may look complicated, but it isn't. First thing to take away is that we have vertical angles. Anytime you have this sort of x intersection, this angle is going to be equal to this angle is going to be equal to this angle because they're vertical angles. So we can just write this angle as 75. Same thing, we have that x shape right here, so we can just write x on this side because of vertical angles. Next thing to take away, we have 1, 2, 3, 4. We have 4 sides, which means that the total sum of all angles is 360 degrees. So we can write 120 plus 120 plus 75 plus x is equal to 360 because x is in degrees, and there's 360 degrees in a quadrilateral. We get, sorry guys, that's 240 plus 75, which is 315. 315 plus x is equal to 360. You can subtract the 315 from both sides. And that gets us 45 degrees as x, which is b. Alright, on my list, the next problem is 74, and it is here. Another number line problem. A number line shown above point E, which is not shown, is the midpoint of AC, and point F not shown is the midpoint of BD. So E is equal to the midpoint AC, and F is equal to the midpoint of BD. Okay, so let's find the midpoint of AC. Okay, so A, which is -4, plus 6, which is C, divided by 2. That's going to give us 2 divided by 2, which is 1. So we know the midpoint of AC is 1. That's right here. Label that as 1, and that's E. This is why the whole midpoint formula works better, because if you were to cross these out, you essentially you just get this, and you can't really differ anything from that. That's just an example, sorry. And next we have to find the midpoint of BD. So we have -2 plus, which is B, plus 10, which is D. It's going to give us 8 divided by 2, which is 4. So we know that F is going to be 4. We know that from 1 to 4 are 3 units. The answer would be J. Now moving on to 77. On a particular vehicle, front tire makes 3 revolutions for every one that the back tire makes. How many times larger is the radius of the back tire than the radius of the front tire? Okay. So we can write the ratio right here. So for every 1 revolution, so front tire, which is Ft, and then back tire, which is Bt. So it takes 3 revolutions for the front tire to equal 1 revolution of the back tire. And whenever we have revolutions, we want to think of circumference. That's basically the general rule. So we can just write it in the we can just write down the circumference formula, which is circumference is equal to 2 pi times the radius. So right here we can apply this. So the circumference of the back tire is going to be 3 times the circumference of the front tire. So that's 2 pi r, and then we have 3 times 2 pi r. So the back tire is going to end up being 3 times bigger. That's our answer B. Next question would be 82, which is up here. If there are 1,000 cubic centimeters in 1 liter and 1,000 cubic milliliters in 1 milliliter, how many cubic milliliters are in 1,000 cubic centimeters? There's a lot of information here, but we can write down some basic formulas. So we know 1 liter is equal to 1,000 cubic cu centimeters. So liter to meter, remember. And 1,000 cubic millimeters in one milliliter. So that's 1 ml, milliliter, remember liter, is equal to 1,000 millimeters. Remember, we're going liters to meters. How many cubic millimeters are there in 1,000 cubic centimeters? So meters to meters. And essentially to find this, we have a common ground. We have liter to liter. So we can just multiply 1,000 cubics times another 1,000. And we get J, which is a million. Because 1,000 times 1,000 is a million. Basically, you know that 1,000, whenever you have one of these, you want to find a common term. The common term here is the liters. Since both of them relate to liters the same way, you can just multiply them. I hope that makes sense. G, which is number 88, goes as followed. The end of the tent has a cross section as shown above. What is D, depth of the tent, if its volume is 216 cubic feet? Now, a lot of people would just plug in the formula LWH for the volume, but you can't do that because this is not a prism, this is a triangle. Sorry, this is a trapezoid. So what you can do is split it into segments. So notice how this formula, the length, width can be our d, alright? But notice that it's just LH times d. So technically, if you can find the area, and then you can multiply it by the depth, and that's exactly what we're going to do here. So we're going to find the area of this side, we're going to find the area of this side, we're going to find the area of this side, and we're just going to multiply it by d to get the total volume of it. And we're going to add all of these up, because you can literally just take away this, find LH, and then multiply it by W later on. Since we don't have D, that's our only option. So we'll do 2 times 6, which is going to be 12, but remember, you have to divide that by 2 because it's a triangle, so this is going to be 6, and this is going to be 6. And then 6 times 4 is 24, that's going to be 24. So now you can do 6 plus 24 is equal to 20, 12 plus 24 is equal to 36. 36 times D is equal to 216. And you can just do 216 divided by 36, and you'll get your answer to be 6. Major takeaway here is that unless it's legitimately a rectangular prism, you cannot use this formula. What you can, however, do is multiply the front surface by the depth or width or length or whatever you want to call it. Yeah, kind of tricky. I bet a lot of students get messed up on this one. Alright, next question is 97. A steel container is shaped like a cube at 10. Okay, so if it's shaped like a cube, we know that much. So let's draw it out first. And 10 feet on each side. A cube always has the same thing, so this is 10, 10, and 10. The container is being filled with water at a rate of 7 cubic feet per meter. So positive 7 CUFM. But the container is leaking at 2 cubic feet per minute. So that's minus 2 CU/FM. If the container is exactly half filled at 9 a.m. and it's half, what time will the container begin to overflow? So let's find the total volume of all of this, which would be 10 times 10 times 10, which is just 1,000. That's the total volume. Next thing we know is that it's exactly half full at 9 a.m. So at 9, it is 500 full, because 1,000 divided by 2 is 500. Now let's look at our rates. We have 7 flowing in but 2 flowing out, so we can just, and since they're both per minute, we can just add them together and we get positive 5 CUFM. So every minute 5 cubic feet of water coming in, so that means we can just do 500 divided by a rate of 5 cubic feet per minute, and then we get that's 100 minutes. In order to fill it up, fill it up to another 500. So if it takes 100 minutes, that is 1 hour plus 40 minutes, because that's 60 plus 40. And add an hour to 9, you get 10. Add 40 minutes to 9, you get 40. So it's full by 10:40 a.m. Alright. Moving on to number 99, right here. So a rectangular floor is 12 feet wide and 16 feet long. Okay, so first off, let's attempt to draw it out. So it's 12 feet by 16 feet. It must be covered with square tiles that are 8 inches, keyword inches, feet, on each side. Assume there is no space between adjacent tiles. If tiles cost $8 each, how much will it cost to buy the tiles needed to cover the floor? Okay, so we have a disagreement with units. We have feet and inches. So what we can, sorry, let me just draw all of this out. So what we have are our individual little tiles, all right, but we don't know how many, and we need to find the cost. So what we can do is we can find the total area and divide it by the total area of the tiles. And that'll show us how many tiles are needed or how many tiles can fit. But the problem with this is that we can't do that because we have a disagreement in units, feet and inches. So we can just convert these to inches. So multiplying by 12 and multiplying by 12. 12 times 12 is 144, so we end up 144 feet by 16 times 2. 16 times 12, which is 192 inches. And this should be 144 inches by 192 inches. Those are your parameters, and since we want to find the total area, we'll multiply them together. 192 times 144 gives us 27648 cubic inches, and then we can just do 27648 cubic inches divided by 8 times 8 inches, which is the surface area of this, 8 times 8, which is 64 cubic inches, and we get 432. Is this your answer? Absolutely not. This just means that there are 432 tiles that are needed. Now we know that the tiles are $8 each, so we can multiply this by 8. 432 times 8 is 3,456, which is E. There are a bunch of big numbers that you have to deal with. You have to be prepared for that on the SAT, so develop quick math or quick multiplication skills, or memorize your multiplication table, whatever you have to do, but a problem like this with such big numbers will probably come up on the test. I believe this is the fastest way, but if you have another slower, more complicated way, then that's also fine. And then our last problem, which is number 100. Which number line below shows the solution to the inequality -4 is less than x, which is less than x over 2, which is less than 2. Okay, so we cannot determine this because we don't have x isolated, so we need to isolate x. So we have -4, which is less than x over 2, which is less than 2. Now we want x on its own, so we'll just multiply x by 2. But whatever we do to the x to this side, we have to do on other side, so we'll do times 2 and times 2. That's going to give us -8 is less than x, which is less than 4. And we could essentially look at it. Thankfully, the dots are all the same, so we won't have to differentiate between filled-in dots and not filled-in dots. But some problems, these dots, some will be filled in, some won't be filled in. Remember, filled-in dots are equal to greater than or equal or less than or equal. Not filled-in dots are greater than or less than. So we can automatically find this right now. So we'll go down to -8, or sorry, we'll just go through the options. This is saying that -2, x is between -2 and 1. No, it isn't, because I'm completely forgetting about -8. This is saying that x is between -4 and 2, which is actually this, but if x wasn't divided by 2, a lot of students would probably get confused and choose G. Do not do that. H would be x is equal to 8 and 4, so maybe. This would mean x goes anywhere from -2 and 1, which is also wrong. And this is saying that x goes anywhere from -8 all the way to 4. So we're left with like 2 solid options, but we can't choose now. So we have to actually look at what the x is saying. So if it's going out from 8, this means that x can be -9, x could be -10, x can be +10, x could be 9. And -8 is not less than -10, so this option does not work, so we have to do K. A good way to check your answer would be to plug in any number on the shaded region onto your number line, and if it's correct, it's correct. That concludes this review of 11 questions. I hope I clarified how to do it and what to do and how to do it. If not, please leave criticism in the comments and I will reply. Alright, thank you, have a nice day.